Hi everyone, so now we're working with the quadratic formula. Like I say, if you watch the completing the square one, don't really like the quadratic formula very much if I'm honest. And it is okay for me to be honest, but every method has a purpose. Every method has a purpose. So the quadratic formula is it's got our discriminant in it, so I can't complain too much, right? That b squared minus 4ac. Remember that discriminant, if it equals 0, then we get just one solution, which is minus b over 2a. If it is less than 0, we get a negative number, so therefore we get no real solutions because we can't square root a negative. And if it's above 0, we get two real distinct roots, okay? And we'll be working with quadratics here then that have two distinct real roots, i.e. b squared minus 4ac is going to be positive. So we should know how to do this. I mean, personally, like I say, I prefer factorizing or completing the square, but sometimes it may be a good idea to resort to the old quadratic formula. So all quadratics come in this form of ax squared plus bx plus c equals 0. Remember, in previous videos, I've really stressed that the quadratic doesn't always equal 0. It only equals 0 when we are interested, when y is 0, when we're interested when it crosses the x-axis. We're trying to find the values of x that make the thing 0, right? Okay, quadratic formula then. So x equals, once we identify what a, b, and c is, this is just filling in some numbers. So a here must be 1, b must be 4, and c must be 2. So x equals minus b, so minus 4 plus or minus square root of b squared. So 4 squared is 16. Take away 4, lots of a, which is 1, and c, which is 2. All over 2 lots of a, so that's 2 times 1. Okay? Sort the top out, so minus 4 plus or minus, and then we've got the square root of 16. Take away 4 times 2, so 8 over 2. And hopefully from our surds video, we know that this is root 2 times root 4 over 2, and root 4 is 2. So this is 2 root 2, and we should be saying then that x equals minus 4 plus 2 root 2 over 2, or x is minus 4 minus 2 root 2 over 2. Okay? And these can be simplified, can't it? Because everything here is divisible by 2. So minus 4 divided by 2 is minus 2, and 2 divided by 2 is just 1. So we get x is minus 2 plus root 2. And same thing here, x is minus 4 divided by 2 is minus 2, and minus 2 divided by 2 is minus 1. So there are our final answers, and we can box them. We'll just quickly go over that again. So this time with different numbers. Are these in the form ax squared plus bx plus c? Yes, this part b is. I'll write my formula, minus b plus or minus b squared minus 4ac over 2a. That's good. So here a must be 3 because it is in line. Remember, get it so the x squared is the first thing. Get it in that order, ax squared plus bx. b must be 10 and c is minus 2. Not 2, minus 2. It's the whole thing. And then we can go straight for x equals then minus b, so minus 10 plus or minus. B squared is 100. Take away 4 lots of a is 3, and c is minus 2. So I would get the calculator out, and on the bottom we've got 2 times a, which is 6. So at the moment we've got x is minus 10 plus or minus, and what is 100? Take away 4 times 3 times minus 2, so that's square root of 124 all over 6. Okay, so split that up. X equals minus 10 plus square root of 124 over 6, and x equals minus 10 minus square root of 124 over 6, and both can be simplified, can't they? Okay, so what is the square root of 124? Just whack that in your calculator. It's 2 root 31. So if I split up the fraction, remember you can split up the tops of fractions. Okay, and x then is minus 10 over 6 and minus 2 root 31 over 6. that can be simplified down. So minus 10 over 6 is the same as minus 5 over 3, plus, and 2 over 6 is the same as a third, so 31 over 3. And x is minus 5 over 3 minus root 31 over 3. So notice the solutions, the only difference is that plus or minus bit. Okay, one solution, two solution. Part C, I know you can do part C. The problem is it's just not in that form, ax squared plus bx plus c equals 0. So you need to move the 7x over. So take away 7x from both sides, take 11 as 0, and then just use the formula as before. Okay, should be alright.